So today we are going to practice some questions on fractions. By the way, apart from fraction, as you shared the topic with me, there multiplication, addition, or subtraction, division is mentioned. So those addition, those different operations are related to fraction, or is it related to a different topic? Simply.
Yeah. Fractions and four operations are both also related.
Okay, so those fractions are for this, for those operations are for fraction only, right? You got it. Okay, then so you have got that topic also. So let us try to do some questions. Hope my screen is visible properly.
Okay.
Okay, did you learn about how do you convert a mixed fraction into a normal fraction? Yes, we haven't learned about that. So before we do this question, we need to learn about that, how do we convert a mixed fraction into a normal fraction. Say for example, there's a fraction 3/5 upon 4. Now we want to convert it into a fraction. It's a mixed fraction. Let's convert into a normal fraction. How do we do that? Any idea? How do we convert it from mixed fraction into a normal fraction, into a proper or into an improper fraction? No worries. See, first of all, simply the denominator should be multiplied with this natural number 3. We have learned that mixed fraction is made up of a natural number and a fraction now.
Yes.
Which one is the natural number here?
3.
3 is a natural number over here. Good. So multiply the denominator 4 with 3. The result is 12. Okay. Whatever result you are getting over here, add this to the numerator. So in the numerator, you'll be getting 3 4s are 12. 12 plus 5, that is 17. 17 upon 4. Did you understood this?
Improper.
Yeah.
That's improper.
That's improper fraction over here.
Yes.
Right now. We can do it for some other values. For example, 9, 8 upon 3, for example. How do you convert this into an improper fraction?
27 plus 8. So multiply 3 times 9. It's equivalent to 27.
27.
And add it to the numerator 8. So it will be 35.
35 upon 3.
3.
Got it now. Good. Okay. Answer the first question.
An improper fraction of 8 whole and 4 9 is...
Same thing has to be done.
Yes.
Simply multiply 9 with 8 and then add 4 to it.
Yes.
What is the answer?
$76.
76
upon 9.
76 upon 9. Good. Okay, next question. Here, question says that what should be multiplied by multiplied to 7 upon 21 so that the resultant value is 12 upon 21.
Done.
What should be multiplied to it? See, one logical way to answer this question is that look at the following two fractions, 7 upon 21 and 12 upon 21.
Yes.
Aren't they like fraction?
Yeah.
They are like fraction. And we know that when two like fractions can be added in a very easy manner. Say for example, you have 3 upon 5 and 4 upon 5. We can add them very easily without the need to take LCM and go to a lengthy process. We can simply add the numerator. Yes, Moz? Simply add the
Yes.
numerator. Since denominator is same, that is 3 plus 4 upon 5. That becomes 7 upon 5. Are you getting it?
No.
Also, is my voice proper to you or not? Is there some background noise?
Huh?
Is there some background noise from my side?
No.
So here the question asks, what should be added to this so that it becomes 12 upon 21? Think about it logically.
Can it be 5 by 21?
Exactly. That is to be 5 upon 21. Okay, no? Good. Now, next question, the equivalent fraction of 3 upon 5 having numerator 24 is going to be what? Solve this. Yes, it's quite simple, no? Yeah. 3 upon 5, its equivalent fraction has got 24 in the numerator. Think about this, with what number it 3 must have been multiplied so that you got 24 in the numerator.
8.
Obviously 8. Thereby 5 also has to be multiplied with 8 now. What's the answer?
8 by 8.
24 upon
24.
5 times 8 equals to 40. Will you not be writing this one? You have to write this one also, no? When you multiply this numerator with 8, denominator also has to be multiplied with 8. Thereby the resultant fraction is 24 upon 14. You got this or not?
What is, wait, let me write the calculations.
The definition for this. Okay. If you want, you can write a question. If you want, you can. A question which you are doing for the first time, you can write that down. Okay. Question number 4. Answer this one. Yes, Moz. Question number 4.
Fractions with the
Question.
same denominators are called equivalent.
No.
Same denominator.
How can it be? Did we not learn about like fraction and unlike fraction?
Oh, like fractions.
Like fraction. Very good. Hope you are getting it. Now let us learn how do we compare the numbers. Then we are going to solve this question. Okay, now. Say
Okay.
for example, you were to have two fractions like this. Comparing fractions. Say we have two fractions like 5 upon 8 and 7 upon 8. Both of them have got same denominators, right?
Yes.
So we are now going to compare their numerators. 1, 2, 3, 4, 5, 6, 7. That's the numerator. And 1, 2, 3, 4, 5. 5 is the numerator in this one. So whichever has got the biggest number in the numerator, that is going to be the bigger fraction. Are you getting it?
Okay.
You got this?
Yes.
Very good. So we have compared a fraction, while this one was a comparison between two like fractions. Now say that you were to have unlike fraction like this, 3 upon 4 and 3 upon 8. Their denominators are different. Then in this case, how we are going to compare them?
Compare with the denominator.
Compare with the denominator.
Denominator.
No, that's not the way how you are going to compare it. See what you can do. You can represent it in this manner. Say for example, you are going to make 4 divisions like this, say. And we have learned that fraction is basically what? Say for example, if I were to ask you, say this is a pie, this is a cake. And if I were to ask you to via shading it, you have to show 3/4 part of this. You have to shade 3/4 part of this cake. Try to understand this. You have to shade 3/4 part of this cake. So you have to, meaning that you have to shade 3 parts out of 4. I'm asking you that you are required to shade 3/4 part of this cake. So you will shade 1, 2, and 3 out of total 4 parts. Now, how many parts are there? 1, 2, 3, 4. So 3 upon 4th part shaded will look like this. Is that clear?
Yes.
Okay. Now here you will shade 3 parts. 1, 2, and 3 out of 4. Is that clear?
Yeah.
Now in this case, you are going to have 8 parts. 1, 2, 3, 4, 5, 6, 7, and 8. And you are going to again shade how many parts?
3.
1, 2, and 3. Now clearly out of the two, look at the size of this fraction and this fraction. Clearly which one looks bigger?
3 by 8.
3 by 8 looks bigger over here. But the thing here is here's the catch in this one. The catch is that whenever we have to compare the fraction with different denominators but same numerator, we have to compare with the denominator only. We have to compare with the denominator only. So the fraction which has got a smaller denominator will be greater. The fraction with the smaller denominator will be greater than the other one. Now look at this thing. Look at the size of this and look at the size of this much only. Focus on what I am pointing at. Look at the length of this. Look at this much and look at this much. Which one looks bigger?
3 by 8.
No, let me shade it once again. So this much is the area of this fraction and this much is the area of this one. So we can say that this one is bigger than the 3 upon 8 now. By looking at it also you can say. But the main thing what you should keep in your mind, in this manner you might get confused or you might forget it. So basically the thing is that if we have to compare unlike fractions with same numerator, then what did I say? Fraction.
Then the fraction with smaller denominator.
Yes. Will be greater.
Greater. But
Right.
how?
Oh, okay. Okay, answer this thing to me. Is 1 upon 2 bigger or is 1 upon 4 bigger? Say you were to have again, take a example of cake again. Say I am giving you half of cake or I am giving you 1/4 of a cake that will look like this. Which one is bigger? This one is half of cake. This is 1/4. Which one is bigger?
Half.
Half. So the smaller the denominator, bigger will be the number. Is that clear?
Okay.
So we had one such example where denominator was same while numerator was equal. So we did discuss that. Okay, you do one question, then we'll be moving. Say you have 7 upon 8 and you have 7 upon, you have let's say 7 upon 12. Which one is bigger?
7 upon 8.
7 upon 8 clearly is the bigger number. Good. Okay, now what about you have third case, case number 3, in which the fraction is unlike, but the numerator is also different. So unlike, have you learned these things in the school?
No.
Okay, unlike fractions. Okay, you told me you were unable to attend the school. So unlike fraction with a different numerator. So let us learn how we are going to do that. All right now. So say for example, you have 6 upon 7 and 3 upon 5. Now in this case, what we are going to do? Yes, Moss? Now we are stuck here now.
Yes.
Neither numerator, neither nor denominator is same. So if the numerator and denominator both are different, then we have to make the denominator same. Denominator has to be made same by finding the equivalent fraction of both the fractions. Okay. You will find equivalent fraction of 6 upon 7 and 3 upon 5. And once you do that, then you will be comparing it. Have you understood what we are going to do?
Yes.
Okay. So the product of 7 and 5 is going to be here 35. The product of 7 and 5 is 35 now.
Yes.
So we will find the equivalent fraction of both the fractions with the denominator 35. So step number 1 says that find product of both the fractions, product of denominator of both the fractions. So here it is 7 times 5, that is 35. So we are looking out for such a equivalent fraction that has got 35 in the denominator. Can you do this one? Try to do this. Yes, Moz. What should be multiplied with 6 upon 7?
3 upon 5.
6 upon 7 should be multiplied with which number?
5.
5. 5 upon 5, that gives you 30 upon 35. Got this?
Yes.
Okay, now answer this one. What is going to be there?
7 upon 7.
7 upon 7, very good. That is 21 upon 35. Now do we have like fraction?
Yes.
Now they are like fraction. Now compare them.
6 upon
Compare
7.
30 upon 35 and this one. 21 upon 35.
6 upon 7 is greater.
6 upon 7 is clearly greater. Very good. Okay, now. So hope you have understood this, how it is done. Okay. Okay, do one more such question. This one you will be doing. Okay, how about we take a question from this one? Do question number 5. Try to do it quickly.
Done.
Yes, that is
3/5.
3 upon 5.
5.
Okay. So you would wrote 15 upon 40, and that would be 24 upon 40. Very good. So that is 24 upon 40, meaning 3 upon 5. Okay, question number 6. Question number 6 here says, what fraction of a day is 6 hours? Can you do this one? A day is 24 hour. So out of that 24 hour, what fraction is 6 hour? This complete circle, let's say, represents 24 hour. So this circle can be divided into different equal parts, na, like 6 hours, 6 hours, 6 hours, 6 hours. Yeah.
Yes.
Okay, na? So you have to represent it in a form of fraction.
Okay, I found the answer.
Yeah.
Now, can I tell the answer?
Yeah, sure.
1/4.
1 upon 4, that is 6 hours upon 24 hours. That is 1 upon 4. Very good. Next question. Are they equal?
Hmm.
Clearly no. Right now. So they are no.
No.
Next.
Is said to be in simplest or lowest form if it's done. Have no common factor except
Okay, let me tell you this one. See, whenever we were having a given fraction in standard form, say for example, 8 upon 16 is not in a standard form, right? What is the standard form of 8 upon 16? Standard form or simplest form, both are same thing. Keep that in mind. Okay. What is the standard form of 8 upon 16?
4/16.
It is further going to be reduced. Further, it is going to be reduced. 4 upon 16 is, by the way, not the correct answer. See, 8 can be written as 2 times 2 times 2.
No, 2 times 4.
Yeah, we can write it in that manner also, as you wish. 2 times 4. Okay. 16 can also be written like, it can be written like 2, 4 times 4. Can't we write it like this? 4 and 4 cancels. 2 cancels 4 by 2 times. You are left with 1 upon 2. Now talking about 1 and 2. They don't have any other common factor apart from 1. You understand what is a factor now?
Yeah.
What is the factor of 6? What are the factors of 6?
1, 2, 4,
1, 2, and
4.
how can it be 4?
I mean 6.
3 now. 3 is also there, and 6. Factors are the numbers from which it will get divided and leave a remainder 0. Meaning that 6 can be divided with 1, with 2, with 3, and 6. And in all cases, remainder left will be 0. So that is called as factor. Was getting it now? Are you actually getting it?
Yeah.
Okay, what about 10?
10, 1, 2, 3.
Is 10 divisible by 3?
No. 10.
You forgot about 5. 10 is divisible by 5 also, no? Okay. So the 1 is divisible by only itself, meaning the factor of 1 is 1 only. and the factor of 2 is 1 and 2. Now looking at 1 and 2, their only common factor is 1 now. The only common factor of 1 and 2 is 1 only. Or
Yes.
take one more example. Say that you were to have a number 3 upon 5. In this fraction, the factors of 3 are as follows. For 3, it is 1 and 3, and for 5, it is
5, 1 and 5.
1 and 5. What is the common factor between them?
1.
Okay, so whenever a fraction will be in its simplest form or a standard form, they have got only one factor. Okay, no? So a fraction is said to be in the simplest or lowest form if its numerator and denominator have no common factor except for 1. Is that clear to you now? Okay, next question.
In an improper fraction, the numerator is the bigger than the denominator.
Good. Next. What is the simplest form of 18 upon 36?
The simplest form of 18, 6 is
See if the two numbers are divisible to each other.
he knows me. I have
Directly cancel it out. 36 can be directly cancelled by 18 now. We find it out.
What did you say?
I said that if the numerator and denominators directly cancel, one of them is getting directly cancelled by another. Like 36 is directly getting cancelled by 18 by 2 times now.
Yes.
Yep. So this can be written like this. 18 upon 36. You can write it as 18 equals to 1 times 18 and 36 equals to what? It equals to basically 2 times 18, isn't it? Yes.
Yes.
18 getting cancelled, then by you are left with 1 upon 2. Is that clear?
Yes.
Okay, I'm giving you one question. Convert 15 upon 45 into its simplest form.
Simplest form. Okay.
Yes, done.
Okay? And you have vowel by voice. Yeah, anything mistakenly, no problem. This week. Vowel this week, you have time today, what is the day? Wednesday. Yeah, vowel, let's see. You're going to meet the
Was it is simple?
Yeah, just stop. 5 times
Okay, look here. 15, I can write this as 1 multiplied 15. 45, can't I simply write it as 3 times 15? For
Yes.
the sake of your convenience, read the table of 15. 15, 3s are 45. So 15 is in the denominator and numerator. It gets cancelled. What are you left with?
1/3.
Okay, do one more. 8 upon 64.
1/64. So 1 times 64. 1 times 32.
Yes? No. That is not correct. Can you show your copy? Can you show your copy to me on the screen? On the to the camera? Project it towards the camera.
Wait. Oh, 1 times 8.
See, we would be writing it like this. 1 times 8 upon 8 times 8. 8 8s are 64. Can't we do it like this? Yes, Moz?
Yes.
So thereby, this 8 and this 8 gets cancelled. You're left with 1 upon 8. Previously, you were answering what was your answer previously?
For 8, 1 times 8, 2 times 32.
Okay, see, 1 times 8 upon 2 times 32. Okay. See, we are going to write the number, we are going to break it down in such a number, such a way that numerator and denominator gets cancelled. We try to write it in such a manner. Okay, now. Or in exam, if you face difficulty, you can write 8 as 2 times 2 and then 2. 2 2s are 4, 4 2s are 8. 64 can be written like this. You can write it like this. 3 2s in the numerator, 3 2s in the denominator. They get cancelled. What is left? 1. What is left? 8 over here. 8 is left in denominator, 1 is left here. So in exam, if you have difficulty, you can break it further like this also. But I have given you a short method, like you can write it in this manner. But if you face difficulty, you can break it like this. After the class, make sure that you solve some questions on it. I will be providing some question. Quickly answer the question number 2.
Which question?
Question number 2, this one.
Oh. Number 1.
You can answer it but just by looking at it, no need to write it.
8 by 15 is greater.
Very good. Next.
4/7 is greater.
Next. Which one?
4/7.
Very good. Next.
5/7.
5 upon 7 is greater. Very good. Also,
Me,
do tell me one more thing. In your school, have you learned about how to represent fractions on a number line? Because particularly regarding the syllabus of your board, I am not very sure whether this topic is there in the syllabus or not.
which
Yeah,
topic?
how fractions are represented on a number line.
Yeah, but I
Representation of
forgot.
fraction on a number line.
Yes, but I forgot how to
Okay,
do it.
it has been taught now. Okay, great.
Yeah, but I
So they,
forgot how to do it.
okay, no worries. We are going to learn it today. Okay, fractions on a number, fractions on a number line. So let us see what is the method to do so. Right now. Say for example, you have a number line. This is 0 and this is 1. Okay, now this is 0, this is 1. So between 0 and 1, there are so many fractions that you can represent. There are so many fractions that you can represent between these two. For example, let's say you are asked a question that you are required to represent a number. Let's say you have got a number like 1 upon, let's say you are required to show a number 4 upon 7 on this number line. Okay, 4 upon 7. Now 4 upon 7, first of all, we need to understand it will lie where? It will lie in between which two number? 4 upon 7, it will lie upon which two number? That is one thing which you need to know first of all.
Behind the middle.
Between 0 and 1, it will be lying actually. It will be lying between 0 and 1. First of all, you will draw a reasonable length of number line as I have drawn over here. Then you will be marking point 0 and 1 on the number line. Okay. Now say that if it's a improper fraction or if it's a proper fraction. If say that if the fraction is an improper fraction, thereby you would be required to convert it into a mixed fraction first. If there's a improper fraction, you'd be required to convert it into a mixed fraction and then proceed. Or say you are having this number 4 upon 7. So between 0 and 7, you will make 7 divisions. How many? 7. 1, 2, 3. Let's take them at bigger intervals. So this is going to be like this. 1, 2, 3, 4, 5, 6, or 7 is going to lie on 1. The 7th one is going to lie on 1. Okay.
Okay.
So this can be written as 1 upon 7, 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7, 6 upon 7. And this 1 over here is 7 upon 7. And what do we know? 7 upon 7 is basically 7, 7 cancel, and you're left with 1 now. You're left with 1 upon 1. 1 upon 1 is basically 1.
Okay.
So where do we write 4 upon 7? Where is it? Here it is.
In between.
Right now. So this is 4 upon 7. This is your 4 upon 7.
Mister, may
Yeah.
I go through?
Okay, sure. Yes, boss. You back?
Yeah.
So let us understand the steps in a detailed manner. Okay, na? By the way, fraction on a number line is basically just like how you represent numbers on a number line. And fraction on a number line is simply a fraction. Number line is simply a number line with fractions represented on it. It's a
Yes.
horizontal line like this, and you represent numbers like this on it. Now, remember, earlier you might have learned this thing like you have a whole number 0 or you have whole number 1, 2, 3, 4 or 5. See that I asked you to show where 1 upon 2, which is a fraction, will lie. Where will it be lying? Yes. So I'm saying that here 1 upon 2, 1 upon 2 is going to lie between 0 and 1. It is going to lie between 0 and 1. One way to look at it is by converting it into decimal. 1 upon 2 is equal to 0 upon 5. So 0 upon 5 is lying where? It is between 0 and 1 now.
Yes.
Right now. Or you can understand it in this manner. Say for on this number line, I am asking you to find a fraction between 0 and 1. So what you are going to do? You are going to add 0 and 1. 0 plus 1 and divided by 2. That is 1 upon 2. So it is going to lie in the middle of 0 and 1. That is 1 upon 2. Are you getting it?
Okay.
Or if someone asks you to find a fraction between 1 and 2, so you simply add 1 and 2 and divide it with 2. That is 3 upon 2. And where it is going to lie? It is going to lie in the middle of 1 and 2. Are you getting it?
Yes.
Similarly, do tell me which is the fraction lying between 2 and 3. Which fraction lies between 2 and 3? Yes. Note the procedure. Simply you have to add the two numbers, like 2 and 3. I'm asking you to find it between 2 and 3. What you need to do? Simply add 2 and 3.
Yes.
Just like we did this now. Find it out yourself.
3 upon 2.
I believe you are not getting it, Moz. I think you are not getting it. Look again.
5 upon 3.
5 upon 3. Okay, now I think now you're getting it. Very good. That is 5 upon 3. Okay, what about a number or fraction between 3 and 4?
7 upon 4.
7 upon 4, 7 upon 2 now.
How?
7 upon how? See, basically you added 3 and 4 and divided it with 2, thereby 7 upon 2. This will be done only when a question asks you to find a fraction between two given whole numbers. In that case only you have to do this. Okay. Now further look at another interesting thing in the number line. Say you have a number line 0. So starting from 0, if we keep adding 1 upon 2, we keep adding 1 upon 2, 0 plus 1 upon 2, that is 1 upon 2. Then we add 1 upon 2 plus 1 upon 2. Thereby you have 1. Half and half equals to 1. Then you add 1 plus again 1 upon 2. Thereby you have 3 upon 2. Okay. Then again to 3 upon 2, you add 1 upon 2. You have 4 upon 2. Okay, na? And to again 4 upon 2, you add 1 upon 2. You have 5 upon 2. Then 5 upon 2 plus 1 upon 2. 5 upon 2 upon plus 1 upon 2. That is 6 upon 2. Now notice this over here. This is 1 upon 2. That is 1. That is 3 upon 2. that is 4 upon 2, then 5 upon 2, then 6 upon 2.
Hmm.
Is it clear to you so far?
Yes.
Now you answer this to me. Can't I write 4 upon 2 as 2?
Huh?
Can we write 4 upon 2 as simply 2? 4 upon 2 is basically 2. Was?
I can't hear you.
Am I audible?
Yeah, now okay.
Can we write 4 upon 2 as 2?
4 upon 2 is 2. Yes.
4 is divided by 2, no? So 2 2s are 4. Yeah. 6 upon 2 can be written as?
2.
How can it be written as 2? 6 divided by 2, that equals to what? 6 upon 2 is what? Simplify it. Simplify this. Simplify 6 upon 2. Simplify the fraction.
1 upon 3.
How can it be 1 upon 3? Oh. Look over here. 6 upon 2. 6 is getting divided by 2. Like 6 divided by 2. So 6 is divisible by 2 by 3 times now.
Yes.
That is going to be 3. As simple as that. Are you getting it?
Yeah.
So there, this 6 upon 2 can be replaced and we can simply write 3 over here. So 3 can be written over here. Right now. So like this, we can proceed further also. 6 upon 2 plus 1 upon 2, that would be then 7 upon 2. 7 upon 2 plus 1 upon 2 would be 8 upon 2. So the next number would be written as 4. Try to visualize it. Try to think about it. Like why I have written 4 over here? Why I have written 3? Because 5 upon 2 plus 1 upon 2 gave you 6 upon 2. 6 upon 2 is basically 2 divided by 6. 6 divided by 2, that is 3. Then 7 upon 2, how it came? Because plus 1 upon 2, that is 7 upon 2. These are like fractions, just add the numerator 7 upon 2. So 7 upon 2 is written here. It cannot be simplified any further. It's in the simplified state. Why I wrote 4 over here? Because 7 upon 2 plus 1 upon 2, that gave me 8 upon 2. 8 upon 2 equals to 4.
Okay.
Okay, no? Are you getting it?
Yes.
Okay, no? All right. Now another interesting thing. Now the finally question: how to represent numbers, represent fractions on a number line. Say if you were to talk about proper fraction, an example of proper fraction is 1 upon 4. Okay, or let's say 2 upon 9. Say the question asks you to represent 2 upon 9 on this number line. How we are going to do this? Okay, let us quickly learn this. So we will draw a number line of convenient length. This will be 0. Okay, now. So to represent this proper fraction on a number line, we will be dividing this number line, joining 0 and 1 into multiple segments. Okay, now, into equal parts. How many equal parts? Say for example, you want to represent 1 upon 4. So you will divide the line between 0 and 1 into 4 equal parts. So to divide it into 4 equal parts, this is part number 1, part number 2, and one more line has to be drawn. So how many parts are there? 1, 2, 3, and 4. 4 parts, no? 1, 2, 3, 4 parts. And 4 is the number of denominator. So you will divide it into as many parts as the denominator of given fraction. Now suppose that we have to mark the number 2 upon 9 on this. Okay, no? Or suppose you want to mark the number 5 upon 6, let's say. Say the question asks you to mark this number 5 upon 6, for example, or say let us understand with the first one only right now, 1 upon 4. So we will be writing 1 upon 2 over here, 1 upon 3, then 1 upon 4 like this. If you can recall, just like we were doing in this in the previous method, like this one over here. 1 minute. How we were proceeding in this method.